Hello, welcome back. I think there was a commercial break. If not, well, my name is Philip Carter. I work on the .NET PM team, and I focus on F#. And so I am here to talk to you today about F# and .NET Core 2.0. So by now, you should probably be aware of the fact that .NET Core 2.0 has shipped. It's available. You can go get it. You can go have fun with it. And you've probably seen quite a bit of stuff with C# and some of the cool stuff that you can do there. But I'm going to show you some of the stuff that you can do with F# and .NET Core today. And we're really excited about this because .NET Core just kind of opens the horizons in terms of all sorts of new people who could be trying F# and functional programming. And I'm really excited to show this stuff off. So the first thing, if you want to get started with F# and .NET Core, is to download .NET Core. So where I'm at here, I'm actually the .NET and C# page, but you can get basically anywhere here to download this thing called the .NET Core SDK. I already have it installed, so I'm not going to show you doing that. And when you have that, you can open up a terminal. You can type .NET, and you'll see this stuff. So I'll type .NET version, and I have .NET version 2.0. So that's all fun and dandy. Let's see what we can do with this command called .NET new. It's a whole bunch of stuff that just came on the screen, but that's OK, because there's a bunch of F# in there. And that's good, because F# and .NET Core 2.0 work really well together. There's kind of the basics, console app, class library. But then some things get a little interesting here. There's this thing called a simple Fable app or a Fable Elmish React app. I'm not going to get into the details of what that means because the next session is going to cover Fable, which is technology that allows you to compile F# into JavaScript. And then you can write F# code that runs in the browser. And because it all runs on .NET Core, you can then have that talking to an F# web server that you have built on .NET Core. You kind of have this whole full stack F# .NET Core thing going on. And so in the next session, that's going to be covered in a bit more detail. But for now, I'm just going to show you how to get started with this stuff and kind of build out some real basic stuff. We can have a library that has a function, and then we call that from a test library, and we test stuff and show that everything works there. So the first thing that I'm going to do is I'm going to go ahead and create a new directory here. Let's call it DNC demo for .NET Conf demo. And I can't spell. There we go. So the first thing I'm going to do is I'm going to create a new solution. If you're new to .NET and you're not really familiar with what a solution is, sort of think of it as this abstraction, sort of this file that can hold multiple projects. And projects can compile into assemblies. And those assemblies can be referenced from other projects. And a solution sort of keeps track of all that sort of stuff. So we're going to create a new solution with the .NET new sln command. So you see I have a dncdemo.sln file there. The next thing I'm going to do is I'm going to create a library project. So I'll just go .NET new library -lang F#, and then the output is going to be a folder that I'm calling fslib. So the name of the library is called fslib for F#lib, and it's going to live inside of the fslib directory. So because I said we wanted to test stuff, I'm going to go ahead and create a new XUnit test. This is using the XUnit test framework. And again, I'm going to go -lang F#, and we'll just call this fstest. Ta-da, it's going to run some restore, and we have everything there. So what I'm going to do now is I'm going to link up these projects with the solution. That's really simple. You just call .NET sln add, and then you point it to the project file that corresponds to the project that you want to add to the solution. And I'm just going to do the same thing here with fstest. All right. And you could run restore, you could run build from all that sort of stuff just to prove that it all works. I actually had to run a .NET restore here because what I'm going to do is I'm going to open this up inside of Visual Studio Code. And Visual Studio Code has excellent support for F# running on .NET Core today, cross-platform. So you don't have to do this on the Mac. You could do this on Windows. You could do it on Linux. But the first thing that you need to do if you want to open this stuff up and get IntelliSense for F# is you need to run .NET Restore. Otherwise, you're going to get a whole bunch of red squiggles, and we don't want that. So you'll see sort of two views here. One is this sort of file view that most of you are probably familiar with if you've used Visual Studio Code before. But the second is this Project Explorer view. This is coming from an F# plugin known as inide F#. So I'm sort of at this extensions thing. I already have it installed, but if you were to just search for F#, the first thing that you get is this thing called inide F#. So this is a plugin that's built by the F# open source community, and it's sort of become sort of this amazing set of tools that sort of transforms Visual Studio Code into a full-fledged IDE that runs cross-platform, and it's supported .NET Core basically from the get-go. The only requirement, if you're not on Windows right now, is that you also have to install Mono. That's because the language service that it calls into and a couple of other its dependencies have not fully ported over to .NET Core, but that's eventually going to happen. So I'm excited for when all you have to do is install .NET Core and install inide F#, and then you can have a cross-platform F# IDE where you can do stuff with .NET Core. Anyways, let's get to a little bit of code. So I have this Project Explorer. You'll see there's this dnc-demo.sln, and underneath it, there's this fslib and fstest. That's the solution, and those are the projects. So we'll go over to the library here. And if you're not familiar with F#, no worries. We're going to sort of explain some of this kind of as we go. So we're going to have this thing called a namespace called fslib. This is sort of how we refer to the thing that we want to call. And I'm going to create a new module that's going to contain a function inside of it. That module, we'll call it piglatin, because I'm a fan of piglatin. And so I'm going to create a new function that takes in a string, be it somebody's name or whatever it is. It's going to be called toPigLatin, and it's going to convert that into the piglatin equivalent. So the first thing that we're going to have to do is recall the rules of piglatin. If it starts with a vowel, then it's the word plus a, where a is ay. And then if not, then it's the word minus, basically you chop off the first character, you stick it at the end of the word, and then you add a at the end. Actually, I was mistaken. This is yay, not a. So in that case, we'll just say if it's banana, this is too much to explain in words, it would be ananabe. So we want to replicate those rules there. So the first thing we're going to have to do is we're going to have to define the set of vowels. So that's really easy. I'll just create an F# set. And we'll say, OK, so that's A, E, I, O, and U. OK, so then we're going to want the first character, because the first thing we want to do is we want to check to see if the first character is a vowel or if it's not. So that's really easy. Because this is a string, I'm just going to index into the first one and pop it right off there. So if you hover over vowels, you can see that that's a set of characters. The first char is a set of chars, so I can check to see if that exists in there. Actually, I'm also going to want to open the system namespace, because I'm going to call a function on the .NET character type. So we're going to see if vowels contains toLower. So we're going to toLower whatever that first char is. There we go. So if it contains the first character, and we had to toLower it because it could be capitalized, but if it wasn't toLowered, then it wouldn't equal any of these. Then we're just going to return str plus yay. Then in the else branch, we're going to do something a little bit different. So I'm going to use F# string slicing syntax. So this is basically a way of saying, well, give me the string that is everything except for the first character, right? It's basically saying, give me a section of the string which corresponds to index 1 all the way until the end. Then we're going to take that first character, but we need to actually turn it into a string, because F# does not do implicit type conversions. So I'm going to call toString on first char, and then we'll append a little a at the end of that. So this looks like it compiles. Let's go ahead and just run that in something called F# Interactive, which is also a part of the inide extension. So this has sort of opened up the terminal window inside of Visual Studio Code. And you see kind of here at the end, there's this thing that says module piglatin, and inside of that, there's this thing called a val toPiglatin. So this is the function signature of the function. This basically says, well, pig Latin takes in a thing called str. And str is type string, and it returns a string. So because that's contained inside of a module, we're going to have to open that up. And I'm going to put two little semicolons in there. That's how you indicate to F# Interactive that you are terminating the buffer that you're typing into. And we'll call to pig Latin on my name. So my name is Philip. And it's Hillip, so that looks like that works. Let's call to pig Latin on Apple. So I have an Apple computer. And it's Apple yay. So that looks like it's behaving the way that I would like. But just to be sure, let's actually put that inside of a test here. So I've opened up this second project called fstest, and inside of that there's a function, a file called tests.fs. Inside of that, it's opening a few namespaces. We're going to open fslib here. That's not defined. I think that's because I need to, oh, yes. Because I was goofy here, I did not bother to add a project reference from fstest to fslib. And so that's why it was giving me a little compile error. So we'll go inside of fstest here, and I'm going to go .NET add reference fslib.fsproj. So that added a reference. And if I go to the File Explorer view here, and I go into the fstest folder, and I open up the project file, you'll notice right here there's this thing called a project reference include, and that just gives me a project reference directly to that project. So just to prove that it works, I will do .NET build. And what this will do is this will actually build the dependent project first, which in this case is fslib, and then it will build the test project. And it all worked. So now, aha, I have fslib available in IntelliSense. Remember, add a project reference before you want to reference that project. So here I have a little test defined in XUnit. If you've ever used XUnit before, this should look somewhat familiar. There's a little bit of funky syntax going on here. First of all, this is an F# attribute. It's defined with the brackets and the angle brackets. So for those of you who like C# and VB, well, C# has these guys, VB has these guys, F# has both, because we're just that awesome. And then underneath that is just a regular F# function, except I have this little double backtick thing going on here. This is a feature in F# that basically allows you to write whatever you want inside of those two backticks, so that in the case of like testing, you can sort of have a descriptive test case name. So let's go ahead and just create a new test here. And you notice there's an error here because I've already defined something called my test, and it's saying, well, hey, I mean, it already exists. So let's call it something else. We'll say that Apple turns into Apple yay. Okay, so I'm going to have an expected output. That expected output is going to be Apple yay. And I'm going to have an actual input. Sorry, actual output. That actual output is going to be, I'm going to call toPig Latin with Apple. And then I'm going to assert that these two are equal. Okay. And then I'll go ahead and just create a third test that tests my name there. So we'll go Philip turns into Hillip. It's fun to pronounce. Okay, got to copy and paste a little bit here because that's what the best developers do. And there we go. So let's go ahead and run .NET test in here. So I've added some test cases. .NET Test is going to build the project because sources have changed. It's going to find all the tests that are there, and it's going to execute them. So it managed to find 3 tests, and all 3 of them passed. And that looks correct because we have 3 of them here. Well, let's see what happens if I create one that always fails. This is always going to fail. And we will say that false is true. That should definitely fail. Da-da-da-da-da. Testing, testing, testing. Running all those bits. And woo! Explosion. But this is where it's actually pretty cool. So you'll notice this is where testing with F# is kind of at a really nice advantage because you see this thing that says fails, test.this is always going to fail. This is, like, I didn't have to sort of come up with this weird camel case or snake case sort of name for this sort of stuff. I could just write basically a whole sentence, right? So if I have sort of this complicated sentence to describe the domain and sort of what the correct behavior needs to look like, I can put that into my F# code right here and I can run that. And this is, because it's on .NET Core, just runs everywhere. So this is a really great feature of F#, and this is kind of why F# is amazing for testing all up. So this is kind of cool, I guess, but it's also a little boring. This is just one function and just one test. Like, I mean, we could probably do something a bit more interesting there. So I am going to get out of here, and I have this thing called giraffe sample. So you may remember that when I typed .NET New, there were a whole bunch of stuff here. And if you caught it, there's this thing called giraffe. So this is a giraffe web app that you can create using technology known as Giraffe, which is a library for creating web services in F# running on .NET Core. So if I were to go to the homepage of that right here, this is where you can find it. It's got a cute little lambda corresponding to the giraffe face there. But anyways, we are going to go into that here because I've already created something. We'll go ahead and restore this thing, and we'll go .NET watch run. So I'll explain what this is a bit, but I have a reference in the project file to a tool that basically watches the files on the file system, kind of corresponding to the directory that you're in. And when those change, it goes and it recompiles everything and then relaunches it. This is really nice if you're doing stuff with a web service because you kind of always want to dink and dunk your way around to getting something to work. So we'll go localhost 5000. We'll go lunch. Aha, so there's a big blob of JSON. This is exactly what I wanted to show you. So I have put some stuff inside of a SQLite database that is running inside of this application. So let's go ahead and explore that because there's a lot to explain in terms of what's going on here, especially for those of you who are new to F#. So I'm actually just going to maximize this so that I have the full screen space. So let's get rid of this welcome page. So a few things to look at here. We'll start with the project file. So because we use the new and fun project files, everything fits within 28 lines of code. And this is mostly just package references. So this is referencing a bunch of ASP.NET Core stuff. You'll notice I have a reference to Microsoft.data.SQLite. So this is basically SQLite access on .NET Core. And I have a reference to Giraffe. I have a reference to giraffe.razor, which I could actually remove, but this allows you to include Razor pages into your Giraffe web app, which I'm not using today, but you could certainly use it if you choose to build your next application in Giraffe. And then I have npoco, which is a data access library that you can basically access anything with. And it's a pretty lightweight ORM that I like. Now you notice I have this thing called sample.db. Whoa, that's not going to open in Visual Studio Code. That's because this is actually a SQLite database that I've embedded into the app. So I have this little thing right here. This might be a little hard to see because it doesn't support zooming. But this is basically just, I've created a table that I've called lunch spots. And the reason why I've done that is because I work at Microsoft. And at Microsoft, we like to get lunch sometimes as a group. But we're sometimes not very decisive about like what we actually want to get. Somebody will say, "Oh man, some Indian food would be nice," or maybe some Malaysian food, or something like that. But we're never really presented with an easy list of just stuff that's available that we know is kind of quick and easy. We'll be able to get in and out within an hour and have some good food. And then additionally, some people are vegetarian and vegan, and so we don't want to pick a place where they can't eat food. So I'm kind of keeping track of that here, where there's just sort of a name, a latitude, a longitude, a particular cuisine associated with this lunch spot, if they have vegetarian options and if they have vegan options. And so what you saw in that blob of JSON was actually the result of everything in that database, just piped through here. So I'm going to show you how that's all working. So because this is SQLite, I just have it just right in the root of the application. You could certainly point to a much larger database if you were to do a production system, but certainly for the purposes of a sample, SQLite is fantastic. If you haven't used it, I really recommend trying it out. The next thing that I want to look at is program.fs. So there's about 77 lines of code here, and there's kind of a lot to go through. So I'm just going to quickly start from the bottom up. All of this right here, the main, this, if you've seen C# and ASP.NET Core, should look really familiar. Creating a web host builder using Kestrel, which is the underlying HTTP server that Giraffe will use, and a bunch of configuration stuff. In this case, we're configuring logging so that if an error happens, we can log it and see what's going on. We're configuring some of the services here. In this case, there's this views folder path here that I could actually probably just delete. We're adding, there's this memory cache, Razor Engine, yada, yada, yada. And then we're configuring the app. So this is something that is called, at startup, we're basically saying, okay, well, we're going to call this method called use Giraffe error handler. So this is actually from the Giraffe library. And it's going to be taking in a function called error handler. So all that does is takes in an exception and a logger, which is iLogger, and it just logs what happened, and it sets the status code of the web server to 500. You might have noticed this little thing right here. Some people call it the fish operator. Some people call it the type rocket operator. That's my personal favorite. And mathematicians call it Kleisli composition. But you can ignore all of that because all it does is compose stuff with other stuff. In this case, the clear response function with setting the status code with sending some text with the message of the exception. So this basically says, okay, well, if an error occurs, exception is thrown on the web server, we're going to clear the response, we're going to set the status code to 500, and we're going to submit some text that gives me the text of the exception. And so that's being used right here. And there's this use static files thing that's just some setup stuff. And then lastly, the important one is this app.useGiraffe. This is where we're actually going to configure where our web API routes come from so that when Kestrel receives a request, it knows what to actually do with it. So in this case, we have this thing called web app. And web app is a function that has this thing called choose. Choose is a fun thing called a combinator. And just, I guess, taking a step back here, I'm going to be submitting a blog post this month that explains this in a bit more detail so I don't have to spend the entire time going through this. But so basically this is saying, okay, well, I've received an incoming request. Well, was that request a GET or was it a POST? Is a decision that the library is going to make. In the case of a GET, we're going to say, okay, well, there's a route that I have called lunch. Does this GET request actually have a lunch inside of it? Yes or no? If it doesn't, then it just short circuits out to the set status code 404, and it sends a text saying not found, because if you sent something that was not /lunch as a GET, then this web server doesn't know what that is, so it's just going to say that we didn't find this. And then if it's a POST, it's going to go to the route called /lunch/add. Now, where it gets a little interesting is, first of all, you've seen this little fish operator a little bit more. I'm composing all gets with this route one. I could actually stick another choose inside of there if I wanted to have another route. So I'm going to go ahead and do that. Okay. Hello. We're going to call it hello. And okay, so I've created a new route here. So basically what's going to happen is when you submit a GET to this web server and the route says hello, we're just going to return hello .conf people. So to see that in action, I'll just do .NET watch run again so we can add more routes and I don't have to go and recompile everything myself. It's going to recognize the files are changed, yada, yada, yada. Now it's running. OK, we're good to go. We'll go localhost 500/hello. And you can see, hello, .NET Conf people. Wasn't that exciting? And if I go ahead and run the lunch thing, get the same response there. That's basically this sort of decision tree happening right here, where in the case of get, it'll do, well, in the case of lunch, it'll call this thing called handle lunch filter, which I'll explain a bit more. In the case of hello, it'll just return that. So there's this handle lunch filter business going on here that I've composed with. So this might seem a little bit obtuse for people if you're not familiar with this very composition-heavy F# or other functional programming languages which do this sort of thing. But handle lunch filter, if we go to the definition here, is just a function that wraps a closure. That closure takes in two parameters, this thing called an HTTP func and this thing called an HTTP context. What this is this is just Giraffe's abstractions over the HTTP pipeline that is running on top of the Kestrel web server. So in this case, handle lunch filter, if we conform to that signature, meaning we define something that, given an HTTP func and an HTTP context, produces an HTTP func result, I can just plug that in to a route right here, and I can compose it with this operator. So if you notice, right here, there's three things that this thing is really doing. The first is it's creating this thing called a filter, which is of type lunch filter. Well, let's go ahead and peek at the definition there. Remember, I told you that iNet F# turns Visual Studio Code into a full-fledged cross-platform IDE, and I meant it when I said it. This thing has peek at definition, which is pretty cool. There we go. That's because I'm being absolutely goofy here. I need to peek at the definition of what a lunch filter is, not at the thing that I've defined called filter. Anyways, lunch filter is just an F# record type. A record is just a collection of values that are named. In this case, it's taking in a cuisine, a thing called vegetarian options, and a thing called vegan options. And these are optionals. So that basically means that this field could have a value inside of it, or it could have nothing inside of it. And that's important because if we want to query this web server and we want to say, okay, well, I want to find everything that corresponds to a particular cuisine, but I don't care about if it has vegetarian options, and I don't care about if it has vegan options, then I can just leave that stuff blank in the request, and I can just say, okay, well, cuisine is, say, Mexican food. Well, then it'll find everything in the database that corresponds to what we specified as the cuisine, and it won't really do any filtering based on vegetarian and vegan options. So I'm going to go back here because this is calling a method called bind query string. So what this does is this basically takes values off of the query string, and then it turns it into one of those filter types. That filter type then gets passed into this layer that I'm calling lunch access. So we can peek at that definition really quickly. This is just a function that takes in a lunch filter. It builds up a SQL query from that. It's kind of some slightly complex code, but it's debuggable, and it's really straightforward. Just, if we have stuff, then we print stuff into SQL, otherwise we don't. And it basically just runs that SQL on the database with this abstraction called the database, which comes from the npoco library that I was referring to before. So I just have a SQLite connection string. I can open the connection. I use this database. It's idisposable, so I just use it within this given scope. And then I fetch a set of lunch spots given the query that was passed. So we can actually test that over here. I'm going to be using Postman because I really like Postman. So we'll go lunch, and if we send that right there, then ta-da, we have everything that we saw there, where there's these lunch items right there with these IDs. So let's send a few parameters in there. In this case, we'll go cuisine, and we'll say that it's Malaysian. Okay, so you notice it built up the query string right there. I'm going to go ahead and send that, and I only get one thing back now. That's because there was only one thing in my database that corresponded to that. Now, I'm going to go ahead and cancel out of .NET Watch Run and just call .NET Run because I want to show you what this looks like when it's debugging. So just so you're aware, To get debugging capabilities with .NET Core, you need to actually install the C# plugin. This will give you the .NET Core debugger. And so the work has been done in inide F# to sort of recognize that debugger. So in this case, I will stick a breakpoint right here at the filter. Should be running here. Let's go ahead and run that through Postman again. Or did that? Oh, I'm not even connected for debugging. That would certainly explain what I need to do here. So setting up debugging is real easy here. Field program, open launch.json. Why are you unhappy? There we go. Okay, so workspace root, insert target framework here. We'll go .NET Core app 2.0. And the name of the program you can just find from right here. It's a .NET Core app 2.0 giraffe sample. Okay. And the next thing it's going to ask me to do is select .NET Core environments. For some reason, I'm having some trickiness right there. Set the launch configuration file. Well, I seem to be lost at configuring this for some reason, which is strange because it worked earlier. Let me just do that. Configure task runner. That's what I wanted to do. There we go. Okay. I'm apparently really bad at clicking buttons. One of which said configure task runner, which you need to do here. There's some future stuff coming to inide that sort of automates this stuff. So that's going to make this a bit easier because if you're like me and you have trouble seeing buttons to click on, then you could run into this problem. But nonetheless, now we are debugging. And I'm going to go back here. I'm going to go ahead and set a breakpoint there. And we will call it with Postman. And there we go. I have been now launched right into this debugging session. And you can see there's some locals. I can see what the context is, all that sort of stuff. But so I'm going to step over here. And so now it's created some stuff. It's created a filter. Now this filter has this thing called sum of Malaysian, because that's what I specified there. I sort of said I want the cuisine to be Malaysian food, but I didn't specify anything for vegan options or vegetarian options. Now those don't actually exist in this filter object. So we'll just step into that, and the first thing we're gonna do is we're gonna call get lunches that has this filter. We're gonna get lunch fetching query. Step into that. All right. And we're just kind of stepping over. So this is just your sort of typical .NET debugging experience that you have with F# and .NET Core 2.0 right now. So I'm going to save you the boredom of watching me step through everything. But lo and behold, it returned exactly what we saw earlier when we were not debugging. So what this sort of shows you is that just today, you could download .NET Core 2.0. You could download inide running in Visual Studio Code, and you can have sort of this full-fledged IDE. You get IntelliSense. You can go to definition. You can peek at definition. There's renaming. There's all sorts of really cool features that inide supports. And then you can also debug your app. And so that's why there are actually people who are using this stuff in production today. It's not just some crazy, wacky thing that just happened right now. There are people out there today using Visual Studio Code, using inide, and using F# running on .NET Core to build their production apps. So this stuff is ready for you to use, and I highly recommend using it. And if you're not really a Visual Studio Code fan, you prefer Visual Studio more than anything else, we also have some pretty good news to share. We're anticipating that full support for F# and .NET Core 2.0 is going to be available in Visual Studio a little bit later this year. We're working really hard at it, and if you've been following along on GitHub, you have probably seen a few pull requests where I've personally commented with images and GIFs and stuff like that, sort of showing it working, but we're still sort of at the final stages of putting everything together, cleaning it up, getting it to a point where it's high quality enough for us to release, and that will happen later this year. So then the landscape of where you can use F# and .NET Core. expands a lot, right? You have Visual Studio with supporting it later this year. You already have Visual Studio Code running basically everywhere at this point. F# and .NET Core is supported in Visual Studio for Mac, and it's also supported in JetBrains Writer. So there's sort of no shortage of editors and IDEs with which you can just have a really good time writing F# code on .NET Core. So let's see here. So I showed a few things, and I showed the Giraffe web server, but Giraffe is not the only technology that you can use in .NET Core today. I'm going to swipe over here. Oh, that's a little big. There's this thing called Suave. And by thing, I mean a library. Suave is just a lightweight, non-blocking web server, and it's just a library that you can use, and it looks somewhat similar to Giraffe. Where you can just start a web server and you can define some routes and have fun there. And even it even uses some of the same syntax where it composes these things known as web parts with right here with themselves. So you see this sort of past syntax composing it with this thing called an OK. They're sort of they take very similar views of the world. It's just they're different libraries, and so what I suggest is trying them both out and seeing what you like more, because you may find yourself preferring Giraffe, you may find yourself preferring Suave, you may find yourself preferring a third option known as Freya. And Freya is another take that is much more functional in nature, makes very heavy use of this feature in F# called computation expressions to sort of have this really amazing type-safe DSL for creating sort of a purely functional web server. So I'll go back to .NET New here, because if your question is, how do I start with all of this stuff? The answer is with .NET New. You'll notice that I have, do I have Freya in here? Yes, I have Freya in here. So I've installed the Freya template. It's called Freya on Kestrel. Freya supports F#. And so that's sort of the way that you get things that are outside of the box from the SDK. There's a particular cool syntax here where you can go .NET New -I or --install. And you just specify, template here, whatever the template name is. And so that actually will install it. It will basically grab a template off of the web that sort of adheres to a particular protocol. It will restore all your tools for you, and then it will put it on your machine so that you could do .NET New, whatever that app is, and create a new one. So sort of the last thing that I am going to do here is I'm going to show off just a little taste of the next session that's going to be coming up. And so the next session is the Fable session, which I mentioned before. Oh, right. I'm already inside of a project. I should probably create a new folder before I do this. Victor, Fable app. Okay. So I'll go .NET New Fable. All right, so it created something called a simple Fable app, and it's got some stuff in there. So in this case, it's .NET Fable npm run start. I actually forget the syntax, but that's good. Because, well, I'm not going to bother Googling this stuff. But basically what you can do is you can go .NET New Fable. It's either npm run start or npm start or some sort of syntax right there. But basically this will launch a Fable app running in your browser. And just to show you some of the basic structure of what that is, this is mixing the JavaScript world with the F# world. Before I open this, I'm just going to go ahead and close this and restore stuff because I want to get IntelliSense. This is using Packet, which is an alternative dependency manager to NuGet. It basically calls all the NuGet stuff in the background, but it has a different way to resolve dependencies, and it's pretty cool. So you notice there's a few things that are a little different here than your traditional F# stuff. So there's a solution file, and there's this package.json though. If you're familiar with JavaScript, this is the JavaScript world. This is how you specify JavaScript dependencies. That's because this application is not your typical .NET app. This right here, this browser.document.getElements by tag name, that sort of stuff. This is grabbing stuff off of the HTML your web page, and it's doing UI stuff in the browser. What this does is this all gets converted into JavaScript through the Babel compiler so that it's compatible with a lot of different browsers. And so because I can't remember off the top of my head the command to actually run this thing, I'm going to defer to the next session, which will go in depth into how to use Fable to write cross-platform UIs with .NET Core. But the main thing that I just wanted to show was that it's really easy to get started with this stuff because all you need to do is install a template into .NET New, and you can just new up one of that stuff. You don't need to go on the web hunting for the right bits and pieces to hack together on your machine to make it all work. The templates are there, and it's ready to go for you to use. So I have a bit of time left, and I am going to answer some questions that I've been getting on the board there. First, I'm going to get a drink of water. So, first question says, what's the history behind the F# name? Well, interesting you should say that. So it's actually not pronounced F#. It's pronounced Foctothorpe because that thing you know as sharp, or as the kids call it a hashtag, it's actually known as an octothorpe. And the F just is prepended to it, and it says Focto. I'm kidding. I have no idea what the history behind the F# name is. I like to call it Foctothorpe, but I think it's because it was created to run on .NET Core. Sorry, not .NET Core. It was created to run on .NET. C# was there, and F is for functional sharp, F#. I'm not really sure. What you could do is you could ask Don Syme on Twitter. He is at dsyme, D-S-Y-M-E. Don could probably tell you because he's the guy who created F#. But if you go around calling it Foctothorpe, then you'll get bonus points in my book. And another question here is, why does the Visual Studio Code C# plugin not recognize F# references? I'm going to take a stab at what that means. What I think this question is referring to is, why doesn't a C# project that I've created in Visual Studio Code, and why isn't it able to recognize references from an F# project? Meaning like project-to-project references, or and basically like, why can't I get IntelliSense from C# to have F# stuff? That's how I'm interpreting this question. The answer is, I have no idea. So I don't work on the C# plugin, so I don't know how they get references. But I'm going to assume that that's something that's going to be worked on at some point in the future, because multi-project solutions with C# and F#, they work in Visual Studio and Visual Studio Code. Sorry, not Visual Studio Code. They work in Visual Studio, they work in Visual Studio for Mac, and they also work in JetBrains Rider. So that'll probably have to work in Visual Studio Code at some point. I just don't know any more details. And I don't have any more questions. So I'm going to assume that's the last of them. And with that time, I'm just going to show a few web pages here because I have the time. The first is the Fable web page. So I mentioned Fable a bit. You're going to see more of it in the next session. This is the website. It's an entire development stack. There's docs. They use all the tools. It works basically everywhere. There's cool videos that you can watch of Alfonso. He's the guy who created it, of showing it off and showing you how to use it. There's a whole bunch of samples, and it's all quite nice. And I also want to show fsharp.org. This is the home of the F# Software Foundation. This is a foundation that's independent of Microsoft, and it basically exists to sort of further F# across the planet. And it's sort of home to like a really large and really nice community of F# people. And so when you join the F# Software Foundation, which is free, I will add, you get access to an extremely active Slack with a large amount of people, and that activity is growing tremendously. And that F# Slack is sort of turning into one of the de facto places to learn how to use F# kind of in any context that you'd like. And experts in there who work on open source libraries that you will likely use at some point are there basically to answer questions for you and just hang out with. And then I also want to show in our official documentation, docs.microsoft.com/.net/F#, we have a huge amount of F# docs available. We have this thing, this is just sort of the homepage, the F# guide. But so if you're interested in learning F# and you just kind of want to see what the syntax is like, we basically cover a lot of syntax in a lot of different contexts as well. So if you just sort of want to see what F# code can look like if you haven't used it before, this is a great place to do that. And finally, we also have some good getting started material where, if you prefer Visual Studio, if you prefer Visual Studio Code, or if you just want to use a command line, we have docs that are available for that. So we'll kind of go through how to install F#, how to write some code, how to work within the IDE, just to sort of get you going. And of course, we have the entire F# language reference here. So if you have any question about how anything in F# works, very oftentimes you'll be able to find it just directly inside of the docs right here. And these are up to date with the latest version of the F# compiler, which is F# 4.1. So that's basically what I have to show you today. Hopefully it was made clear that despite the fact that I have trouble seeing buttons and clicking on them and sometimes typing, it's actually pretty easy to get started with F# and .NET Core. You don't really need a whole lot, and you can do a lot of stuff. And so in the next session that Alfonso has put together for you, he's going to show you how you can really dive into doing some pretty incredible stuff with F#. So stay tuned for that.